Hey guys, welcome back. Today we're going to be learning about specifics on inputs and outputs. So our learning target today, we're going to determine inputs and outputs for a given function. And I'm actually going to highlight some of what's in our success criteria today because some of these look very similar to each other. The first one, I can identify the input given the output of a graph. Second, I can identify the output given the input of a graph. So we're going to be able to go both ways today at the end of the hour. I can create a table given inputs and a rule. So we're going to create a table from inputs and a rule. Lastly, I can graph a function from a table. Okay, so we're going to be able to do all four of those things by the end of this lesson. Let's take a look at the first example. Determine the input given the output or vice versa from the graph. So the first one that I have, I see that they give us the input of 2. Okay, so input is going to represent x. And I'm going to write these at the top. Input, that's x. Output, that's y. We learned that in the last few lessons. So what this is saying is, when is x equal to 2? Okay, so let's look on the graph where x is equal to 2. Here's 2 on the x-axis. Then use the graph, travel your eyes up to the actual graph where it lands on the line, and then see what the y value is going to be, because that's going to be the output. So when the input is 2, the output is going to be 1. Now let's do part B, and here we're looking for the output of 5, and then we're going to look for the input. Now remember, output is y, so we have to go on the graph and look for where y is equal to -5. Well, here's -5 on the y-axis. Let's use our eyes and look over to where -5 lines up with the actual graph. There's the point on the graph, and then travel up to the x-axis, which will give us our input. So our input, when our output is -5, is also -5. The last example we have here, it's asking for what if the input is -2. Okay, so I'm going to look now where the graph is -2 on the x-axis. Okay, so here's -2. Again, I'm going to look to where that meets up with the graph. There's the point on the graph, and then the output value on the y-axis is -1. So when the input is -2, the output is going to be -1. Okay, so when you're asked to give one or the other, you're basically just reading the graph where those values are and being able to identify which one's x and which one's y. So let's have you guys give this a try. Let's take a look at a second example. It says create a table and graph for the equation y equals -1/2 x. So I'm first going to start with a table so that I can just plot those points. So I have my input x and my output y. And really what I'm doing is I'm just going to substitute any inputs that I choose in for the variable x. Now in order to spread it out throughout this graph, I'm just going to pick a couple of spread out points, some negative, some positive. So I'm going to say let's start with -4, let's do -2, 0, 2, and 4. I picked those numbers specifically because I knew that I was going to have to multiply x by 1/2. And I wanted to pick numbers that were even so that when I multiplied them by 1/2 that I get a whole number and it's easy to graph. So what I'm going to do is I'm going to show some work here and then I'm going to do it in my head. So y equals -1/2 and then I'm going to plug in -4 first. So times -4. Now you can type this in your calculator. I'm going to do this in my brain. I know that 1/2 of 4 is 2 and that a negative times a negative is a positive. So this output is going to be 2. I'm going to do the same thing for all of the other ones. So I'm going to multiply -2 by -1/2, which is going to be 1. I'm going to multiply 0 by -1/2, which is going to be 0. I'm going to multiply 2 by -1/2, which is -1. And I'm going to multiply 4 by -1/2, which is -2. Now I'm ready to plot. I'm going to make my points a little bit bigger to highlight the points from my table. Okay, so I have -4, +2. I have -2, +1, 0, 0, 1, 2, -1, and 4, -2. So now that I have all the points that I created in my table on the graph, I just want to connect them. Because you can multiply any number by a half, not just the numbers that I picked in the table. You can multiply anything. So I should show that even the decimals and fractions are included. All the points that lie in between these points are included in this graph. So when you make a table, try to list at least 3 points, if not 4 to 5 points to get a good snapshot, and then just plot them down and connect the dots. So let's have you guys give this a try. Alright, so I've got one last example for you guys. It says create a table and a graph from the following context. So this time we're looking at words. Miss Svetlik runs at a pace of 6 miles per hour. So again, we should always remember our form y equals mx, where m is going to be our slope or rate of change. Okay, well, we should identify what that rate of change is, where in the context it says 6 miles per hour. So my rate of change is going to be 6 miles every 1 hour, or just 6. But I need to define which of my variables is the miles and which one is the hours. Well, my input's going to be the hours, time. I'm not going to be able to see how far I ran unless I know how long I was running for. So I'm going to make the hours my x, and I'm going to make the miles my y. So that means y, the distance, is going to be equal to 6 miles per, meaning multiply, timesing by the hours, x. So there's my equation that I should be able to create a table for. Do you have to create the equation in order to make the table? No. Okay, but I think it's a little easier to create the equation in order to see what the graph looks like. So this was the equation y equals 6x. I'm just going to generate some points here. So I have x, I have y. If I have, I'm going to stay in the positive numbers because negative hours don't make sense and negative distances in miles don't make sense. So I'm going to start with 0 and just count up by ones to represent hours passing. I can't say that I ever run for 4 hours, but I have run for a couple hours before in different long distance running. So if I were to take my x, 0, and multiply it by 6, I get 0. 1 times 6 is 6. 2 times 6 is 12. All I'm doing is plugging all of my x's into the x in the equation that I generated. Okay, all of those x's get plugged into the x in the equation. So 3 times 6, that's 18, and 4 times 6, that's 24. So now I'm ready to plot. If you notice on this graph, there's looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tick marks. And I want to be able to reach in my outputs 24. So that makes me want to count by 2s so that I can at least see all the points that I chose in the table. Now, if you go up by 2s and you're feeling like the numbers are a little cluttered, you can always skip a grid line and count by 4s instead. So instead of going 2, 4, 6 like that, it's starting to get cluttered. You can skip and go 4, 8, 12, 16, 18, and 20. We only got up to 20 on that one. Maybe I counted wrong. Okay, but we'll at least show the first 4 points instead of my 5th point. Okay, so I scaled the graph differently just so that I could be able to reach at least 18 or 24. If you don't get all of the points that you create in your table on your graph, that's okay. It doesn't say that you have to reach a certain point. Okay, so I'm gonna get a little bit bigger here, change my color, and actually plot these down. So I have 0, 0, 1, 6, here's 0, 0, 1, 6. Let's see, we had 2, 12, and 3, 18. Okay, so there's our points. And I'm not perfect. They don't look like they're in a perfectly straight line, but that's because, you know, humans are imperfect and sometimes we're not going to be able to draw it very perfect. Okay, but I'm also going to draw a line through these points to signify that I can run for a half hour, I can run for 20 minutes, okay, but I'm actually not going to put the line all the way through. I'm going to put a dotted line. I'm going to say don't include this part. Okay, the reason why I'm not including that part is because it doesn't make sense in the real life situation. I'm not going to have negative hours, and I'm also not going to have negative miles, and that's what the third quadrant is. It's negative, negative, which doesn't make sense. So I'm only going to start at 0, 0, and then stay in the first quadrant. That would be a graph that represents this situation. Let's have you guys give this a try on your last U-Try. Guys, so I hope that was a quick and easy lesson for you. Today we determined inputs and outputs for a given function. Did a lot with inputs and outputs. We were able to identify the inputs given the outputs. We were able to identify the outputs given the inputs. Both 1 and 2 were in example 1. And then we created a table given inputs and a rule or an equation. That was example 2. And then our last one, that was example 3, I can graph a function from a table. And actually that was example 3 and example 2. I included you guys to do the graph on both of those. Okay, if you have any questions, please let me know, and you can go ahead and grab your practice.